In this video, I'll be discussing various objective type questions on heating effect of electric current and practical applications. Let's begin with the first question. When an electrical current is passed through a conductor, dash is produced in it. Option A, heat. Option B, charge. Option C, thermo effect. And option D, none of the above. Answer is heat. Option A is the correct answer. See, when we connect the wire to a cell or a battery, okay, current will be flowing through it and the heat produced around it, heat or magnetic effect will be produced. Magnetic field will be produced around it. So we don't have the option magnetic field, so the answer is heat. Joule's law of heating states that heat produced in the conductor is directly proportional to. See, we know the statement Joule's law, the heat produced is directly proportional to square of the current, then directly proportional to resistance and directly proportional to time. See, all of the above is the correct answer. The heating effect of electric current is utilized here. That means the heat which is produced when the current is passed by which devices we need to see. It's electric iron, room heater, water heater. Yes, all of the above. All of the above is the correct answer. Fuse has dash melting point. See, fuse has low melting point because fuse should melt and then protect the equipment from damage. That means when the current is above the rated value, excess current will be flowing. Okay, so it has to melt. So it should have low melting point. Answer A is the correct answer. Fuse is always connected in dash with the live wire. See, we'll be having, this is the phase and this is neutral, and we'll be connecting whatever the devices will connect across parallelly like this, electric bulb or water heater, whatever the equipment, and this is the fuse. Fuse should always be connected in series with this phase. Phase is also called live wire. Okay, so option B is the correct answer. It should be connected in series. Assertion and reason type question. A fuse wire is always connected in parallel with the main line. Just now we have seen that it is connected in series, not in parallel. So assertion is wrong. Reason is, if a large current than the specified value, I told you rated value, yes, when it flows it has to melt. Yes, so reason is correct but assertion is wrong. So it must be option D. Assertion is false, reason is correct or true. Why is tungsten used for filament of electric lamp? What may be the reason? See, we know the tungsten filament used in the electric bulb, that is having very high melting point, because at a high melting point, at a high temperature, it will glow, the light will glow. So therefore it should have high melting point and high resistivity and high resistance, and it should not oxidize at high temperature. So here we have two options only, very high melting point and high resistivity. So option D will be the correct answer. Both A and B will be correct. It should not have low melting point. If it is having low melting point, it will melt and doesn't give light. Why is a lead tin alloy used for fuse wire? Give reason for the answer. Just I have discussed what will be the characteristics of a fuse wire. Fuse wire should have low melting point. Okay, option C is the correct answer. State whether true or false. The wire which melts breaks the circuit and prevents the damage of various appliances in the household connections is called fuse wire. That's right. That's true. State true or false. A fuse is a safety device which melts when current flowing through it is less than expected value. No, it must be greater than expected value. So it is false. A fuse wire is a wire of low melting point. Where do we have low melting point? Here. Low melting point is there in option A as well as option B. Low melting point, that's right. But whether it has low resistance or high resistance, it must have high resistance and low melting point. So option B is correct. Option B is correct. Clear? It should have high resistance and low melting point. Which element is used exclusively for the filament of electric bulb? It's the tungsten filament. Okay, so tungsten is the filament which is used in the electric bulb. Assertion and reason type question. Tungsten metal is used for making filament of incandescent lamps. The melting point of tungsten is very low. That's right. First one, assertion is true because we use tungsten for making the filament of incandescent lamp. The melting point of tungsten is very low. No, it should not be low. It must be high melting point in order to give light or to glow. So this is wrong. So assertion is true, reason is false. It must be option C. Assertion is true and reason is false. Which is the expression for the heat energy produced in the wire of resistance R and carrying current I? So the heat produced will be, we have seen that heat produced is equal to power into time, I square R into T. So option C is the correct answer. Which substance is used for making resistance coil of electric heater? We use nichrome alloy. Okay. Which of the following devices convert electrical energy into heat? See, when we supply electricity, electric current, heat should be produced and that heat should be useful for us. Electric heater, yes, it is used for heating the water, and electric iron, yes, it is used for ironing the clothes. So both A and B will be the correct answer. It is not electric bulb. Electric bulb, what do we do with the heat that is produced with the electric bulb? Isn't it? So which of the following devices convert electrical energy into heat? Even electric bulb will get converted to heat, but along with that it gives light. Clear? Two wires of equal length, one of copper and other of manganese alloy, have the same thickness. Which of these can be used for electrical heating devices? Two wires of equal length, one of copper and another manganese. Copper and manganese. See, alloy, usually alloy will use for heating devices. Which kind of alloy we will use? It should have high melting point, high resistivity, high resistance. It should not oxidize at high temperature. So that means the alloy, right? We can't use copper for heating devices. So manganese is the correct answer. Why does electric bulb becomes dim when an electric heater in parallel circuit is switched on? see, we have electric bulb, okay, and along with that we'll be having electric heater, and this is phase neutral. It has been connected to phase neutral of the supply in a parallel circuit. So more current, see, this electric heater will have less resistance, therefore more current will flow through this electric heater. Here it has got high resistance. Resistance is high, so less current will flow through this electric bulb. That's why it will be dim. The resistance of heater coil is less than the electric bulb. That is the correct answer. Option A is the correct answer. And also, more current flows through heater than the electric bulb. More current will flow through the heater because it has less resistance. Okay, heater has less resistance. More current will flow through the heater. That's right. So both A and B. Option C is the correct answer. Both A and B. An electric iron has a rating of 750 watt 220 volt. What is the current passing through it? So here we are given with the power as well as the voltage. We need to find the current. How to find current? Current is equal to power by voltage. So that is equal to 750 divided by 220. If you divide, you will get 3.4 amps. Option C is the correct answer. An electric iron has a rating of 750 watt 220 volt. What is its resistance when it is in use? So here power is given and the voltage is given. We need to find out the resistance. How to find resistance? We know power is equal to V square by R, and R is equal to V square by P. So 220 into 220 divided by P. The power is 750. Okay. So if you divide, you will get 64.7 ohms. Option D is the correct answer. A geyser is rated 1500 watt 250 volt connected to 250 volt main. What amount of current is drawn? So here in this case, power is given, voltage is given. We need to find current. So current is equal to power by voltage. Since we know power is equal to product of voltage and current, from this we can get this. So 1500 is the power divided by voltage is 250. Okay, so if we divide, we will be getting 25 6 are 150. So 6 amps is the correct answer. Which has a higher resistance, a 50 watt 220 volt lamp or 25 watt 220 volt lamp? See, we know that the 50 watt bulb will glow more. The wattage is more. The bulb 50 watt will glow more. That means here current is more. That means resistance is less. Isn't it? So 25 watt bulb will have high resistance. Because of its high resistance, the current will be less. As the current is less, the power will also be less. So we know 25 watt is less power, right? So it will have more resistance and less current. So option C is the correct answer. An electric iron consumes energy at a rate of 840 watt when heating at a maximum rate. The voltage is 220. What is the value of the current? Power is given, voltage is given. We need to find the current. Current is equal to power by voltage. This we have already seen. So given power is 840 divided by 220, can cancel, and you get a 3.82. Option A is the correct answer. An electric iron of resistance 20 ohm takes a current of 5 amps. How much heat is developed in 30 seconds? So here in this, resistance is given, current is given, okay, and the time is given. So how to find the heat? Heat is equal to I square RT. So what is I? It is 5 into 5 square into R. R is 20 into time. Time is 30 seconds. We can get in joules. So 25 twos are 25 twos are 50. So here 20. So 500. So 500 into 30, which is 15,000. So 15 kilojoule is the answer, is the heat produced. Two conducting wires of same material and of equal length and equal diameter. That means they are made up of the same material, clear, are first connected in series and then connected in parallel across the same potential. That means voltage is given and length and diameter, area is the same. So we know the formula for resistance is rho L by A. Here in this case, area and length is same in sim, so resistivity will be equal to resistance only, okay. And here the voltage is given, and what will be the ratio of the heat produced when connected in series to heat produced when connected in parallel. So we know the formula V square by R into T. That will be another formula for the heat produced. Actually the heat produced formula is I square RT, but we don't have current given here. So same potential is given, so we need to use this formula. V square by Rs into T, V square divided by Rp into T. So T get cancelled, V square get cancelled. 1 by Rs is equal to 1 by Rp. That means I will get Hs by Hp is equal to Rp divided by Rs. So how to find Rp? When connected in parallel, both are having the same resistance. Okay. So parallel resistance, what is the formula for two resistance connected in parallel having same value? R into R divided by R plus R. Okay. This will be Rp value. So R square by 2R. R square by 2R means R square by 2R means RR get cancelled. You get R by P. R by 2. So we get R by 2. Isn't it? Then Rs. So when two resistance are connected in series, then it is having same value of resistance, means total resistance will be R1 plus R2. So we should take R1 plus R2 means R plus R is 2R. Okay. Now this R get cancelled. Then we get 1 divided by 4. So Hs by Hp will be 1 divided by 4. So option C is the correct answer. 1:4. That will be the ratio of the heat produced in series to heat produced in parallel. The fuse is placed in series with device. That's right. Fuse consists of a piece of material made up of metal or an alloy of appropriate melting point. That's also right. But why it is connected in series? Have they given the reason? No, it is not apt reason. So therefore we can say that both A and R are true and R is not the correct explanation of A. So option B is the correct answer. 100 joule of heat is produced each second in a 4 ohm resistance. The potential difference across the resistor would be. So here in this case they are asking you to find out potential difference, whereas the heat is given, okay, and the resistance is given, R is given. So we need to use the formula H is equal to V square divided by R into T. Time is given 1 second. So we can substitute that and find out what is the value of V. So cross multiply this, we get V square is equal to H into R divided by T. So here what is H? H is 100 joule into R is 400 divided by 1. So V square is 400, then what will be V? V is equal to square root of 400, which is going to be 20 volt. Option A is the correct answer. Assertion: fuse wire must have high resistance and low melting point. That is correct. Fuse is used to protect the circuit. That is also correct. Whether the reason is the correct statement of the assertion, that we need to see. See, fuse is used to protect the circuit. Okay, that's also correct. But whether the reason, it is linking to the reason, yes. Because here it is used to protect. In order to protect only, it should have low melting point and high resistance. So therefore, if both assertion and reason are true, reason is the correct explanation of assertion. It must not be if, you should have both. For everything they have given if. No problem. So the effects produced by electric current would be, we know as I already discussed, that when we connect a wire to the cell or a battery, heat is produced as well as magnetic field is produced. So both A and B would be the correct answer. If the current passing through a conductor is doubled, what will be the change in the heat produced? See, if the current is doubled, what will be the heat? See, say for example, here the current is I, it is doubled, 2I the whole square. That means it will be 4 times. It becomes 4 times. 4I square RT we get. So 4 times the heat produced. Which effect of current is utilized in electric light bulb? We use heating effect. Okay, heating effect is used. The device which work on the heating effect of electric current is electric heater and electric fuse, not the fan. Okay, so it must be both B and C. Option D will be the correct answer. Fan, the heat produced by the fan is not used for any other purpose, right? So therefore we can't take that for heating effect. The gas which are filled in the filament type electric light bulbs is what kind of gas? It's inert gas. So inert gas is argon gas, helium, neon, argon, and also nitrogen. Nitrogen and argon gas is filled. Okay, why it is? To prolong for long life. And in an electric bulb, all the amount of electric power is converted into light. Whether it's true? No. Electric bulb, fuel is converted to heat also, no? So it's false. Why argon or nitrogen is filled in an electric bulb? To prevent oxidation. That's right. To prevent oxidation of the tungsten filament used in the bulb, to prolong and to make the bulb look more attractive. No, that's wrong. To minimize the electric current. That's wrong. None of the above. Now option A is the correct answer. To prevent the oxidation. The heat produced in a wire of resistance X when a current Y flows through it in time Z is given by. See, instead of resistance R they have given X, and instead of current I they have given Y, and instead of time they have given Z. Now what will be the formula for H? H is equal to I square RT, isn't it? Now instead of I, what we have? We have Y here. So Y square. Instead of R, what we have? X. Instead of T, what we have? Z. So it must be Y square XZ or XY square Z. X is Y square Z. Option B is the correct answer. Which of the following characteristic is not suitable for fuse wire. See, fuse wire, how it should be? It should be thin, and it should be thin and short, and it should be having low melting point. It should have higher resistance than rest of the wiring. So thick and short, that is, should not be the suitable characteristic of fuse wire. So therefore this is the correct answer, option B, thick and. We have discussed various objective type questions on heating effect of electric current and practical applications. If you like the video, kindly click the like button and share to all your friends, and subscribe my channel to get the notifications for the upcoming videos. Thank you.